plus D1 over D1 plus D2 times the width, as you can see on the screen. This is the formula for calculating the mode. And we said that the mode is the most occurring frequency. So if you look at the frequency column here, you realize that the most occurring frequency is 10, right? As far as we are looking at people who fall within ages 15 to 19, it's having a frequency of what? 10. So this is the most occurring frequency. And yesterday, we tried explaining the formula. We said that L1 is the lower class boundary of the class that contains the modal class. Right. Lower class boundary, that is L1. D1 is the difference between the modal frequency and the frequency immediately preceding the modal frequency. D2 is the difference between the modal frequency and the frequency immediately after the modal frequency. W is the width. You made these explanations clear. Right. So with this, we are saying that the frequency with the most people having the ages between 15 to 19 is 10. As you can see, it's 10. It's the highest, the most occurring frequency. It's 10. So if you're finding the L1, the lower class boundary of the class that contains the most occurring frequency, the lower class boundary will be what? 14.5. I told you how to calculate for lower class boundary. You subtract 0.5 from the lower class, add 0.5 to the upper class. If you remember, we said that the upper limit and the lower limit. So here, the lower class boundary is 14.5 because this is where the most occurring frequency is. 15 minus 0.5 will be 14.5, as you can see here. D1 is the difference. So when we say difference, it's subtraction. A difference between the frequency that contains the highest, frequency, the class that contains the highest frequency, and the frequency immediately preceding the most occurring frequency. So if you look at this, it is 10 minus 1. Then D2 is the frequency with the mode minus the frequency after, and this is 10 minus 3. 10 minus 3. And the width is 5. I've told you that to find the width, start counting from the lower limit to the upper limit. 40, 41, 42, 43, 44. Or even if you are starting from 0 to 4, 0, 1, 2, 3, 4. When you count your fingers, you realize that it's 5. So the width is 5. If you have to put this into the formula, then you're going to get 14.5 plus 10 minus 1, which is the D1, over D1 again, 10 minus 1, plus, as you can see in the formula, D2, 10 minus 7, times 5. If you break it down, please, can you see my screen and can you hear me?
Yes, sir.
Yes, sir.
When we break it down, thank you very much. When you break it down, it is 14.5 plus 9. Can you mute yourself? Plus 9 over 9 plus 7. We are subtracting, right? Times 5. When you break it further down, it is 14.5 plus 9 times 5 is what? 45 over 9 plus 6 is what? 16. When we divide 45 by 16 and we add it to 14.5, we get a mode of 17.3138. So the modal age is 17.313 years. Please bring the unit. Years. The modal age is 17.313 years. So averagely, or approximately They are saying that the modal age is 70
Please,
years.
sir, please kindly go back again. How you get the LI 14.5
L1,
and
the Li.
L1 14.5,
So we
the
are
LI,
saying that
yeah.
we have to locate. Yesterday, were you in class?
Yes, sir.
We said L1. You have the slides, right? Or you don't? Okay, let me go back. L1, L1 is the lower class boundary of the class containing the modal mark or modal age. When you go through this one, the frequency, which one is the most occurring frequency here? The person who has the question.
1.
The
One.
most
No, 10.
occurring
That is
highest.
That is 1.
that is
That is
15
15
to
to
19.
19.
10.
Yes. And that is 10.
That is 10.
Those
Yes, sir.
okay, let me break it down. Those who fall within the ages of 0 to 4, it is occurring 4 times. Those who fall within the ages of 5 to 9 occurred once. 10 to 14 occurred once. 15 to 19 occurred 10 times.
10 times.
So when I say the most occurring frequency, it is those who fall within the ages of 15 to what? 19, which is 10, is the highest. Is that clear?
Yes, sir.
Yes, sir.
So it is not one. I know why you are saying one because one is occurring 1, 2, 3. No, that's not what we mean. What this one means is that people who fall within the ages of 40 to 44 is just one person. Right? So when you look at it very carefully, a lot of people fall within these ages, 15 to 19, can. But the formula is saying that L1 is the lower class boundary of the modal class. The modal class is 15 to 19 because 10 people are within these ages. So the lower class boundary will be what? How do we find class boundaries?
I think you subtract 0.5 from 15.
Yes.
Then you add 0.5 to the 19.
Very good. So the lower class boundary is the one with the lowest limit. And the upper class boundary is the one at the upper limit. Please, is that clear?
Yes, sir.
Yes, sir, it's clear.
Sir, please come again.
Probably. Let me show you. Maybe probably if I let me try and add that section to it. You can see my screen. I'm trying to do something to make it clearer. So I'm adding another column, and I'm going to label this class boundary. I'm coming to find a class boundary. Okay. So here is normally we will start from the down because I mean the table has turned. We've turned the table intentionally to see whether.
So I was also suggesting if you can regroup the ages, because initially we need to start from the bottom, but I think that is a
Yes,
little
it's
bit
intentional.
making the
Intentional.
yes.
We do that intentionally. If you go and it is turned, don't say, oh, because it's turned, I can't do it. That's why we are showing you this. So 0 minus 0.5, those with calculators, what will it be? 0 minus 0.5, what will it be? Those with calculators, help us.
So minus 0.5.
Minus
So
0.
that will be 14.5.
Okay. So let's try and go it one after the other. Let me try to minimize this font size so that it will fit. So negative 0.5 to 4.5. Do you agree?
Yes, sir.
Yes, sir.
Yes, sir.
Then this one will be
And then
4.5 to 9.5. You agree? Then this one will be
Yes, sir.
9.5 to
5 to 14.
14.5.
0.5.
This one will be 14.5 to 19.5. 19.5 to 24.5. These are the class boundaries we are calculating, right? 24.5 to 29.5. 29.5 to 34.5. 34.5 to 39.5. 39.5 to 44.5. So this is class boundaries. Are you with me? This is class boundaries.
Yes, sir.
And this is how we plan it. Any question? Is there a question, please? Someone was mentioning my name.
no, sir.
Okay. Now, the one on the left is the lower class boundary. The one on the right is the upper class boundary. The ones on the left, they are the lowest in each class. And the ones on the right are the upper class boundary for each class. Do you understand?
Yes, sir.
So if L1 is, so now we have agreed that the mode is in this class. The mode is here because it's occurring 10 times. Those between the ages of 15 to 19 years, occurring 10 times. And L1 is lower class boundary of the class that contains the modal age. That will be this. This is the lower class boundary of that class. Do you agree now? Have you seen it?
Yes, sir.
Yes.
Yes, sir.
Okay,
Yes,
someone,
sir.
I think someone wants to ask a question. Lambert. Hello, Lambert.
Sir,
Your hand is up.
I'm sorry. Yes, I'm sorry, sir. I joined recently and I'm lost. I don't know
Please, Lambert,
the person
I
we
cannot
are.
help you. I can't help you.
I
Because
just want to please, sir. I just want to know the session.
the what?
I mean I believe we are in unit 2, but the session I want to know.
Session 5.
Okay, sir. Thank you.
It's there. Can't you see at the top? You need 2 session 5. Can you see?
Okay, sir. Yes,
Okay.
sir. Yes, sir.
Late. I can't help you because this is something we planned that we meet today. I cannot move ahead, then go back. We have to finish it today. And fortunately for us, I think after this, we have theories of social conflict, right?
Yes, sir.
Yes, sir.
So at least we can add that period to this period so that we can complete it. Right. So now, do you agree where the 14.5 is coming from? Have you seen it? That is the lower class boundary of the class that contains the modal age. 14.5. This one. I've highlighted it in red. Then D1 is the difference between the modal age, the frequency of the modal age, and the frequency before this one. Someone would say is the one at the up. No, the table has turned. Do you understand? So the before is now here, the 1, not the 3. Do you agree? Do you agree?
The 10th table is not even seen on the screen.
Hello?
We agree.
So we agree.
So we agree, sir.
Agree.
So, sir,
Okay.
sir,
Yes.
sir, in case you've given this type of question and you don't want to get yourself confused, can you rearrange it like from the highest,
You
like
can
you turn
rearrange
it
it. Yes, you
so
can
that
do
you
it.
won't be confused?
Yes, you can do it. That's why I'm telling you that there are people who will go by this. But if you want to go by this, then I'm making you aware that the before is the one at the down and the after is the one on top. Do you understand?
Yes, sir. Yes, sir.
But
Yes,
if you turn,
yes, sir.
if you rearrange or you turn the table to your convenience, that is fine. You don't have any problem. You don't have any problem with anyone. So when you put this in the formula, that is what you have calculated to this level, which is 17.313. Please, is it understood?
Yes, sir.
If you have any question, please ask. Now let's go to the median.
Hello, sir.
Yes.
I raised my hand. Thank you very
Okay.
much, sir. Yes, sir. Why can't the D1 cancel the D1 on top?
No, it can't cancel. The formula is D1 over D1 plus D2. So you are not supposed to cancel, but look for D1 and put their values there.
I mean, even after putting the values, you can't cancel it out. Why?
Mathematically, you can't. Unless unless you make it 9 over 9 plus 9 over 7. I don't want you to confuse yourself. Don't
Sir, please, sir, please, can I have him?
you can help him.
Mr. Kanyiri, you see the D1 at the top and the D1 at the down are not the same because the D1 at the down is addition to D2, so it's a combination of numbers. If it is D1 at the top isolated and then D1 at the down, let's say they separate it with a bracket. That one you can do the cancellation, the top and the down. But this one is addition. They added it to a number, and that is a formula. So you cannot cancel that.
Okay.
If you are done, if you are done proof of formulas, this one I think you will know that one is plus between the two variables. You cannot cancel them.
Okay. Thank you very much.
Thank you for the assistance. Now let's move on to the median. Now, yesterday I told you whenever you are asked to find a median, you first have to find a median position. The median position is given as n over 2. N over 2. So n over 2, as you can see, n over 2, I believe you can see on the left hand side, is 14th position. N over 2 is 28, right? The n is 28 over will give us 14th position. So when you have found the median, you need the median position first. Now, how do you locate that class or that age group on the table? You need a cumulative frequency column, a column for cumulative frequency. Again, if you don't want trouble, turn the table upside down and start adding the frequencies from the top. But if you can handle it, you can start adding from the down here. So 4 will come.
Okroko, please mute yourself. You are giving her feedback.
4 plus 1 is 5. 5 plus 1 is 6. 6 plus 10 is 16. 16 plus 3 is 19. 19 plus 5 is 24. 24 plus 3 is 27. 27 plus 0 is still 27. 27 plus 1 is 28. So if you don't want trouble, rearrange the table and add from the top to the down. But if you can handle it like this, then it means you have to add from the down to the top. Please, that's clear.
Yes, sir.
Okay.
Now, once you have calculated for your cumulative frequency column, how do you locate the 14th position? The 14th position using the cumulative frequency. Who will help us? Where can we locate 14th? Which age interval Can we locate the 14th position? Anybody? Anyone?
Says between the
The
same
ages
figure,
of 15,
the same
the
figure,
ages of
which is
15 to 19.
For the sake of those who don't understand, can you show us where or how you got that age group? If you can demonstrate to us using the cumulative frequency.
so, the position which is the 14th can be located. So bring your distance back, where the frequency, the cumulative frequency. So our position, which is the nth position, is 14, and then 14 is going to be within the 16th column from 4, 5, 6, and then the 16th. So the 14th position will be within the 16th, and you locate the 16th to the 15th to 9th, which is the age mark.
Please, do you all understand?
No, sir.
No, sir.
Take it again.
No, sir.
Confusion, Basa. Please, can you go over again? They say they don't understand.
So we just calculated for the nth position, which is the n over 2, and then we said the n represents the number of samples. So when you add the entire frequency, you get 28. So 28 over 2 give you 14. So with the 14, you locate it within the cumulative frequency. So bring this in your table. You locate the 14 within the cumulative frequency, and we all know the cumulative frequency starts with 4, 5, 6, 16, 19, 24, 27, 27 to 28. So if you look at 14 as a figure, it locates within from the 4 to the 16. And from 16, if you want to locate the age, you then trace the 16 to the 15 to the 19th.
You still get it now? Do you get it now?
Yes, sir. Yes, sir.
Those who said no, please, let's see you. You understand it now? Someone has
Yes, sir.
raised. Let me see. In Kumecha.
Yes, sir. I wanted to add some small explanation to what my brother has explained.
Okay, please go on.
So by finding the 14th position, you add 4 plus 5 will give you 9. 9 plus 6. Then to that 9 plus 6 will give us.
No. Hello. The cumulative frequency, right, is we adding the frequency values, right? 4 will come first. 4 plus 1 is 5. 5 plus 1 is 6. 6 plus 10 is 13. So now, when you want to find the 18th position, it's not a matter of adding anything again. Just go within this column and locate where the 14th position can be found. 14 is higher than 4. So definitely the people are above 4. It's higher than 5. Definitely the people are above 5. It is higher than 6. So the 14th position people are above 6. But 16, it means that the people are likely to be found here. The 14th position people, they are beyond 6, but they are within this particular region. Please, do you understand? Hello, those who said they don't.
Yes, sir.
Yes, sir.
Okay, please, the ladies who said they don't understand, let me see by hand. Let me see. I want to give you an example of a position, then you try locating it for me. Vicentia. Okay, so Vicentia, if I ask you, if you calculate the median position, and let's say, assuming this one was 30, assuming the sample size, the n was, let's say, 40, right? Was 40. So 40 divided by 2, right? Finding the median position is n over 2, right? So 40 divided by 2 will be 20. So If I ask you to find the 20th position using a cumulative frequency, find the 20th position. Essentially, look at the cumulative frequency values and tell me where the 20th position will be. Can you help us, Essential?
Yes, it will be around 24 because
No,
it's less than
yes,
9.
the 24. It's more than 19. Fantastic. So the person is likely to be at 24. Then you trace it to the age group. You trace it to the age interval, which is 25 to 29. So the median class is within this region, assuming that you are looking for 20th position. Do you understand, Resentia?
Yes, sir.
Now, assuming you've calculated for the median position and you got the n over 2 after calculating, you got, let's say, I want to find something. Let's say 17. You are looking for 17th position. 17th position. Where will it fall? I want someone. Musa, your hand is up. Hello, Musa. Okay, Amanda.
Sir,
17th position. Where will it fall?
please, the 19th.
So what median age group are you looking at?
The 20 to 24.
That's all. That's all.
Yes, sir.
When you're able to locate the median age group, then you can easily,
Okay.
when you're able to locate the median age group, then you can easily locate the lower class boundary.
Mother, you've muted yourself. Oh.
Sir, we can't hear you. You mute yourself, sir. Sir, you mute yourself, please.
Hello, can you hear me now?
Yes, sir. Yes, sir.
Yes, sir.
So
Yes, sir.
what I'm saying is that one is 14th position. The median class will be 15 to 19. What is the lower class boundary of that median class? 14.5. Just as we did for the mode, 14.5. Then the formula is L1 is 14.5. Then N is the total sample size. That the total frequency, as you can see from 28. That's N. In the formula means frequency immediately in the median class. Who can help us? Who can help me?
Say your question.
You.
I'm saying that CF in the formula, this CF, this CF, it means the median class or the median age. So look at what's the cumulative frequency figure that immediately precedes the class that contains the median age. Anyone to help us? Let me see. Someone has showed interest.
36.
It's what?
It's 6.
6.
Why is it 6? Can you demonstrate to us?
Yes, sir. The figure before the median class on the frequency table is 6, because 6 before the 16. And we located the 16 to the age. So 6 before that figure. So the cumulative frequency before the class is 6.
Do you all agree? If you
Yes,
don't,
sir.
let's know and help you.
No,
Please,
sir.
do you all agree? Let's who don't agree, give us your problem so that we can help you. Yes. So we can move on.
Yes, sir.
So the CF is 6. Cumulative frequency immediately preceding the class that contains the median class is 6. Then the F is the frequency of the median class. So when we go back to the table, what is the frequency of the median class? This is it. The frequency of the median class is 10. This is the frequency of the median class. Then the width is the same. The width is 5. Then we are counting our fingers. So when you get these values, you put them in the formula. So MD is equal to 14.5 plus, as the formula is saying, N over 2, 28 over 2 minus cumulative frequency immediately preceding the class that contains the median age is 6 over the frequency of the median age or the median class is 10 times width. The width is 5. So 28 over 2 is 14. 14 minus 6 is 8. Do you understand? I've broken the numerator down. So 14.5 plus 8 over 10 times 5. So 8 times 5 is 40. 40 divided by 10 is 4. When we add the 4 to 15.9, it gives us 18.5. So the actual median age is 18.5 years. So approximately the actual median age is 19 years. Please, that's clear. Hello?
Yes, sir.
Yes, sir.
Okay. Now, we also have to find the median, the mean. The mean is giving us summation fx over summation f. Learn the formulas. So we need to find the x values. We need to multiply it by the frequency, then we sum it. Then we sum the frequency, then we divide the two. So how do we get the x values from here? Can anybody help us? How do we get the x values? How do we get the x values for the age?
So I think the
Anyone?
x values are the midpoint.
The midpoint. So how do you find the midpoint?
Yes, sir. So with the midpoint, you use the frequency.
No. How do you calculate midpoint?
So you add and divide by 2 also. Yes.
Yes. So with the
You add what
midpoint,
and
you add
divide
the
what?
lower limit. You add the lower limit. The interval class, the lower limit plus upper limit, and divide by 2.
Okay. So you add the lower limit 40 plus 44 divided by 2, you get the midpoint, which is the x, 42. 35 plus 39 divided by 2 gives you 37. 30 plus 34 divided by 2 gives you this. You do that for all the classes. 0 plus 4 divided by 2 gives you 2. So this is the x values that represent each age class. Right. Now, once we have found the x, the formula is saying summation fx. So what do we do again? What do
You
we do?
multiply the frequency.
We
That is
add
frequency
F.
1 multiplied by the x. That is the midpoint. That's 1 times 42. So you
So
get
you multiply the fx is f times x. You multiply the frequency by the corresponding x value, the midpoint. So 1 times 42 gives us 42. 0 times 37 gives us 0. You do it for each of the levels or the classes. Once you are done finding fx, the formula says sum it. Sum it means you are adding all this. You add all this and get summation fx. So when you get summation fx, you divide by summation f, which is 28 here. So in the formula, when you put this in the formula, the sum fx is 536 over summation f, which is 28, which gives us 19.14. So the average age of the class is 19.14, which is approximately 19. Please, that's clear.
Yes, sir.
Please, is that clear?
Yes, sir.
Yes.
Okay.
Yes, sir.
Do you have a question? Please, do you have a question? Okay, then let's move on. So the next thing we are going to look at, so we have done with the mean, mode, median for on group and group data. Now let's look at a tool called box and whisker plot. Box and whisker plot is also something we use to analyze data. Right. It's a method for graphically depicting groups of numerical data. Groups of numerical data. Groups of numerical data through their quartiles. Box plot is constructed into two parts: the box and a set of whiskers, one leading to the lowest value and another leading to the highest value. You get to see how it looks like very soon. So there are five numbers or values needed to create a box plot. We need 5 things to create a box plot. We need the lowest value of the data set. We need the first quartile. We need the second quartile, which is the median, the third quartile, and the highest value of the data set. So we need the lowest values, we need the highest value, we need the first quartile, second quartile, and third quartile. So the steps are simple. Rearrange the data in ascending or descending order. Find the actual median, which is the second quartile, Q2. Find the median to the left of the actual median, which is Q1. Then find the median to the right of the actual median, which is Q3. So first quartile, second quartile, third quartile, the lowest value, and the highest value. All right. Now let's start with an example. Assuming I give you this data set, as you can see, this data set, 5, 8, 2, 9, 4, 5, 6, 7, 8. The first thing is rearrange the data as the steps has indicated to you. So we're going to rearrange this from the ascending order, from the lowest to the highest. Now, when we rearrange this, this will be 2, 4, 5, 6, 5, 5, 6, 7, 8, 8, 9. If you want to find a median, you count from the left, count from the right. The middle value is the median. That is the Q2. So 1, 2, 3, 4. Then 1, 2, 3, 4. So the middle value is 6. So Q2 is 6. What is the lowest value? Which is the lowest value? The lowest value in this data set is 2, as you can see. The highest value in this data set is 9. Now let's find second quartile and third quartile. The actual median to the left, the median to the left of the actual median is the first quartile, and the median to the right of the actual median is the third quartile. So once we have found this actual median, which is the actual median, Q2. What is the median to the left of the quartile? If we are going to look at it from here, this is the left. You have to find a median here too. To the left side, you have to find this median. Then you have to find the median to the right side as well. That will be Q3. So here, if you want to find a median, we count from the right 1, 2, then 1, 2. You have two numbers in the middle, 4 and 5, right? So you find the median over there. 4 plus 5 divided by 2. It will be 9 divided by 2, which gives us what? 4.5 as the first quartile, which is Q1, right? Then you also find the third quartile on the right, the median to the right of the actual median. So 7, 8, 8, 9. So when you count from the right and left, you see you come to meet two numbers in the middle, which is 8 and 8. Add 8 to 8, it gives us 16. 16 divided by 2 gives us 8. So the third quartile, which is Q3, is 8. So we have found all the values we need to draw the box and whisker plots. Right. So that is how we find those values. Now let's try another example. Then we can know what we are looking for. Create a box plot for the scores in a quiz. 18, 22, 22, 17, 30, 18, and 12. The first thing you need to do, rearrange it in ascending or descending order. So you rearrange it, starting from the lowest, 12, 17, 18, 18, 22, 22, and 30. Have you seen it? Now, if you want to find Q2, the actual median, we come from the left and come from the right to locate the middle number. So 1, 2, 3, 1, 2, 3. The middle number is 18. So the actual median, which is Q2, is 18. Now that we found the actual median, it says that let's find the Q1 first quartile. In finding the Q1, we look at the median to the left of the actual median. So this is the left-hand side. When you're finding 1, 2, 3, what is the middle number? The middle number is 7. So Q1 is 7. Then Q3, when we are counting from the right.
Is it 17 or 7? Sorry.
Sorry, 17. 17, sorry. 17, sorry. Can you see it?
Yes, sir. Yes, sir.
All right. So, what is Q3? What will be Q3?
20.
Q3.
The third quarter.
22.
20. Fantastic. So, on the right-hand side, 22 is in the middle here. It's in the middle. So the third quartile is the median or after or above the actual median. 20, 22, 23. So Q3 is what? 22. So the maximum value from here, the maximum value is 30. The minimum value is 12. And that is what we... Now, this is how the box and... So this is the box. The one in the middle is the box.
Can you mute yourself? Can go.
The one here is the box, as you can see. And the tail is the whisker. The tail are the whiskers. So that now that we have the values, you see that we draw the maximum is 30. This is the 30, right? So if you can see the diagram, this is 30. This is the maximum. The minimum is what? 12. So you see, this is 10, the minimum tail of the box, the whisker. Now, what is the first quartile? What is the third quartile? And what is the second quartile? Yes, the second quartile is 18. The first quartile is 7. So the third quartile is 22. You see the dot here, 22. Then 17. So you plot the 17. And the second quartile, which is the median, is 8. Can you hear me, class?
Sir, now we can hear you.
So when you have the first quartile value, second quartile, and third quartile, and you have the maximum and the minimum value, you can draw the box is this one. So you plot the first quartile, second quartile, third quartile within the box, and the whiskers are the maximum and the minimum values. Any question, please? Please, do you have any question?
Sir, please, the box where you were
The whole thing is
presenting,
not.
where you were presenting the box, where that place the network was not good enough. So the box, how do you get the box in plotting the points inside, or you intentionally do the box?
So you found your values already. The Q1, Q2, Q3, right? You know your minimum values and the maximum value. So here,
Sure.
the vertical axis, you label your diagram, or you draw it to scale. So here is 0, 5, 10, 15, 20, 25, 30, 35, right? Basically, the drawn to scale will depend on the values you have here. The minimum value is, what do you call it? The minimum value, which is Q1. Sorry, the minimum value here is 12. And the maximum value is 10, 30. So you have to draw it to scale so that it will fit. Right. Now, once you have labeled here, the minimum value is 12, which is the whisker. Have you seen this line? If you can see my cursor.
Yes, I can
it's
see
12.
it, sir.
You see, it's 12.
Yes,
it's
sir.
just above 10. It's 12. Then the maximum value is 30. You see 30 when you put it here. It's 30.
Yes, sir.
Have you seen it?
Yes, sir.
So that is the tail. Then what is the Q1? Q1 is 17.
18.
Or
Q1 is 17.
Q1 is 17.
17.
So you have to locate it. This is 15. This is 15. Then you plot it somewhere 17, right? That's the first dot you see. Have you seen it?
Yes, sir.
Yes, sir.
Please, have you seen it?
Yes, sir.
Then
Yes, sir.
Q2 is the actual mean. This one, Q2, actual mean, 18. Plot it 2 in a box. 18 will be somewhere here. Where is the star is? You see the star?
Yes, sir.
That's 8. Then Q3 Q3 is 22. So if you look at 20, you can plot 22 above 20. That's the third dot. Q3.
Yes, sir.
And these are found in a box. So you just draw, to capture these three quartiles. That's how we
so my
draw
question, so my question here is the drawing of the box. How do you manage to draw the length of the box? Does it have?
Yes, you use the. Does it have what?
Does it have any measurement that you take to draw the box, or you draw it anyhow? That.
No, yes, but you have to locate the numbers, the values you have calculated. You locate them and draw it. It's not drawn to scale, but locate the values, the minimum and the maximum. Then the rest will come in the box. Then you draw a line to connect it, as you can see. Please, is that clear?
Yes, sir.
Yes, sir.
No.
Sir, this means that.
I'm saying that you cannot.
So this means that if you want to burn the box, it is advisable that you plot the distance, the dots before drawing the box.
Yes, so that you know that the box would capture the first quarter, second quarter,
Yes, sir.
and third
Thank
quarter.
you,
They are
sir.
found in the box. And the whiskers would capture the maximum and the minimum. Please, that's clear.
Yes, sir.
Yes, sir, it's clear. So then, what
Don't
about
answer
the?
yourself, sir.
Sir,
Lambert,
sir, I want to.
Lambert, please.
Yes, I want to find out
Yes.
the figures before drawing the box. I'm talking about the range from 0 to 35. Is there any scale that, I mean, a specific scale that is used, or how do you get those figures? Because per the Q1.
It depends on the values I've given to you.
Okay.
Hello, please,
Hello,
hold
sir.
on. You see the values? I gave you from 18. I
Yeah.
gave you from 12 to 30.
12.
So you
Yes,
have
sir.
to draw the scale that will capture these values.
Okay.
Are you following?
Thank you, sir.
I
Yes,
give
sir.
you starting from 40 going, and you want to draw a scale that will not reach there, how could you draw the box? So you have to draw for a scale that may capture the values you've been given.
Okay, sir.
So I chose 0, 5, 10 because it will capture from the minimum to the maximum. 12 to 30 will be found within this range, this scale. That's why I use that. Please, that's clear.
Yes, sir.
Sir, please, I have a question.
Okay, sir.
What's your question?
Sir, please, why is it that one of the plotting is in dots form, two are in dots form, and I think that's the second quartile, so that one is in a star form? Hi, sir.
Hello. Please, your network. I couldn't hear the last part.
Okay, sir. Sir, please, I'm talking about the plotting. I think that's the one in the star, the one that was the star was used to plot. So I think that one is the second quarter. So I'm asking, why is that one? Why did you use the star to plot that one? But the others, the second and
dots.
the third are dots.
I just want to differentiate that the actual median is the actual median is the median,
Okay, sir.
right?
Thank you, sir.
I just wanted to use the star to differentiate between
Yes, sir. Thank you, sir.
Okay. Now let's go to the next one, which is the mid-range. The mid-range is also a rough estimate of the middle. It is computed by the range is like the midpoint, calculating midpoint, the formula. So it's the lowest value plus the highest value divided by 2, right? So an example is in the last 2 rainy seasons, the city of Accra and Kumasi recorded a number of waterline breaks per month. Find the mid-range. So on the left-hand side, you see Accra, the data for Accra. On the right-hand side, you see the data for Kumasi. Right. So here, the mid-range for Accra is the lowest value, 1, plus the highest value, 8, divided by 2. So the mid-range is 4.5 for Accra. You do same for Kumasi. The mid-range, the lowest value is 1, the highest value is 16, divided by 2. 17 over 2 is equal to 8.5. Right. So basically, we are recording more, rainfall on average in Kumasi than in Accra because this is 8.5 and this is 4.5. So it is higher in Kumasi than it is in Accra. But it is higher because, of course, they recorded one highest water line break, which is 16 in Kumasi, which has, of course, made the value higher. So the extreme value there is influencing the average we have recorded. Lambert, your hand is up. Hello, Lambert.
Sorry, sir.
Okay.
So, meaning,
let's continue.
Meaning in Kumasi, the result is misleading because of the stream value. If you in actual sense.
Yes,
Okay.
in actual sense, it's misleading. Right. But ideally, but per the formula, this is how it's supposed to be calculated. Do you understand? So when you see an extreme values or outliers, my advice is you have to be careful the kind of tool you use. Okay. Now let's continue. If not, we'll not finish today. Let's continue with the last section, which is Unit 6. Unit 6 is also quite loaded. In here, we are looking at measures of dispersion. We are going to look at the range. We'll look at quartile deviations and semi-interquartile range. We'll calculate the mean deviation, variance, and standard deviation. Then we'll end it with the coefficient of variation. These are also tools to measure variability. So the central tendency is the mean mode median is not enough for describing a data. Sometimes you need the measures of dispersion to tell you more information about a data. Right. Especially when the averages are giving you the same results. Assuming you want to go to the market to buy paint. We have Azar and Deluxe paint. You calculate the averages and they have the same mean for both paints. You are indecisive because you have the same average. How do you decide which brand of paint to buy when the averages are the same? That is when the measures of dispersion comes in to give you extra information to make a decision, especially when the averages are the same. Please, that's clear. So the degree to which a data tend to spread around the average values is called the measures of dispersion. How are the data widely spread around the average? So if I 18, 19, 20, 15, 16, 17, then I find the average. And the average is, let's say, 16. How is the average 16 spread or deviated from the other individual scores? So if someone had 18, how is it deviated from the average, which is 15 or 16? This is where the measures of dispersion comes in. So we'll be looking at some types of Assuming you are talking about brands of paint, brand A, brand B, and you ask people questions about, of course, the durability of the brand. Some are saying 10 months, 60 months, 50 months, 30 months, 40 months, 20 months for brand A. Others are also saying that in brand B is 35, 45, 30, 35, 40, 25 in terms of the months they last. And you calculate the average. It is summation X over N, where you add these values divided by the number of observation, which is 6. So you add all this 210 over 6. It gives you 35 months. When you do the same thing for brand B, which is Azar, you add all, it gives you 210 over 6, 35 months. So when you use the averages, which is the mean, to calculate, you see you are getting the same month. So you are still not sure which brand will last longer. That is where the dispersion comes in to help you take a decision. So since the means are equal, one might conclude that both brands last equally well. But this might not be well the case when the dispersion of both brands of paint are considered. Then you see that you may not get it right. If you look at these two, brand B, the differences between the two is all the months recorded. The difference is 5, 5, 5, 5, 5, 5, 5. But if you look at brand A, the difference is 10, 10, 10, 10, 10, 10, 10. If you look at it very carefully, 10, 20, 30, 40, 50, 60. Here is 25, 30, so 35, 40, 45. So the difference is 5, 5. Because there's gap in brand B is smaller than the gap in brand A. In terms of the variations or the dispersion, it is smaller than brand A. And since the dispersion is smaller in brand B, we will say that brand B lasts longer than brand A because of the dispersion. They are not widely scattered. But with brand A, it is wide, 10 difference. So if the averages, which is the mean, is not telling the story, you can use the dispersion, how scattered they are, to tell you how consistent one product is performing than the other product. Please, is that clear?
Yes, sir.
Is it
Yes, sir.
clear? Okay. So let's look at the types. We have range, we have mean deviation, quartile deviation, variance, and standard deviation. So we are going to look about, I think about 4 of them will be okay. We look at the range, mean deviation, variance, and standard deviation, and probably coefficient of variation. Yeah, you can look at that as well. Then we'll be fine. So the range is the simplest of all the measures of dispersion. The range is calculated by having the highest value minus the lowest value. Its symbol is R. So if you are calculating the range, it's highest value minus the lowest value in the data set. It measures the width of the distribution. So if you're using the same brand of paint example, the range for brand A is 60 minus 10. The highest value is 60, then the lowest month is 10. It gives you 50 months. The brand B is also 45 minus 25, which also gives you 20 months. So the range gives you an idea of which of the brands are lasting longer. So brand A shows that 50 months separate the highest value from the lowest value. For brand B, 20 months separate the highest value from the lowest value. So we can use the range to calculate. Then another example is we looking at salaries of workers in probably in a university, right? HOD, this is just tentative figures. It's not real. If HODs are receiving 100,000 cedis a year, administrators, lecturers, cleaners, messengers, if you have to find the range, is the highest value, which is 100,000, minus the lowest value, which is 15,000. It gives you a value of 85,000 Ghana cedis. Right. So this is how we calculate for the range. Any question with range calculation? Do you have any questions?
No, sir.
Calculating the range.
No,
Okay,
sir.
that's fine. Now let's go to mean deviation. the absolute deviation of the sample. Can you hear me?
Yes, sir.
Please, can you hear me?
Now we can hear you now.
Yes, sir.
Hello?
Yes, sir.
Yes, sir, we can
Yes,
hear you,
sir.
sir.
Yes, sir.
So the mean deviation is the absolute deviation of the sample mean. So we will do that for on-group data, and we'll do that for group data, like we are doing for the averages on group and group. The formula for mean deviation for on-group data is this: summation bar x minus the mean. Then you bring another bar over n. The n is the number of observation. Then x, the dot is the mean. The x with the two dots is the mean. Is the deviation of the individual scores. Right. How are the individual scores deviated from or moving away from the average? Now let's look at examples and see how best we can learn this particular one. So I can ask you, find the mean deviation of the raw data below. And I'll give you this x values, right? If this is the formula, summation bar x minus the mean, close the bar, over n. Let the formula guide you. In the formula, you need the mean. You need the mean. When you find the mean, you subtract it from the x scores. Then you introduce the bar. Then you sum. You divide by the number of observation, which is n. So the first thing you do for mean deviation is find the mean for raw data. So mean is summation x over n. So when you sum all these values, it gives you a sum of 70 over n. N is the number of observation. 1, 2, 3, 4, 5. So 70 over 5 gives you a mean of 14. Once we found the mean, the formula is saying that subtract it from the individual scores. So x, right, that is what the formula is saying. So 10 minus 14, 11 minus 14, 12 minus 14, 17 minus 14, 20 minus 14. So when you do that subtraction, you get -4, -3, -2, 3, and 6. Are we on course?
Yes, sir.
Yes, sir.
Now, once you are done subtracting the mean from individual scores, introduce the bars. These bars simply means that anything negative tends to positive. That is the subscript bar, what it means. These bars. Anything which is negative here turns positive. Now let's introduce the bars. Once we introduce the bar in this formula, as the formula is saying, -4 becomes 4. -3 becomes 3. -2 becomes 2. 3 becomes 3. 6 becomes 6. Anything negative becomes positive once the bars are introduced. Once you are done, in the formula, it says sum everything. So we introduce the sum. So summation bar x minus the mean bar is equal to, we adding all this, which will give us 18. Please, is that clear? Gives us 18.
Yes,
So
sir.
the numerator is 18 over n. N is 5. So mean deviation is equal to 18 over 5, which gives us 3.6. Any question? Any question, please, for mean deviation
Sir, please go over
of
again.
raw data? I should go over, right?
Yes, sir.
So
Yes, sir.
normally, we'll give you a raw data x values like this. Like this. which is x bar, this mean, is 14. Now, once you have found the mean in the formula, it says x minus the mean. So you're going to subtract the 14 from the x values, which are these x values. So we move to the second column. So x minus the mean, 10 minus 14. This is the x value, and this is the mean, 14. 11 minus 14, 12 minus 14, 17 minus 14, 20 minus 14. Do you understand up to that level, please?
Yes, sir.
Hello, the lady who says as you go over.
Yes,
Please,
sir.
you understand?
Yes, sir.
Now, in the formula, it means that you're going to subtract x minus the mean. When we subtract that, you get 10 minus 14 is what? Negative 4. 11 minus 14 is negative 3. 12 minus 14 is negative 2. 17 minus 14 is 3. 20 minus 14 is 6. That is the subtraction you've done. It doesn't end there. After you have subtracted it, introduce the bar. There is 2 bars. Why you introduce those 2 bars? It means that anything negative turns positive. That is what the bars means. So the next column is reintroducing the bars. So this negative 4 becomes positive. Negative 3 becomes positive 3. Negative 2 becomes positive 2. 3 is 3, 6 is 6. Do you understand up to this level?
Yes, sir.
Now, hello.
Hello.
Can I continue?
Yes, sir.
Hello, sir.
Yes, sir. You can continue.
Hello, sir.
Yes, please.
Sir, excuse me. It's like the model I had here, the figures, or I don't know if you are going by your own example, but per the model I have here, the mean deviation on the raw data, the figures are different.
What figures are you having?
I have the X, I have 17, 18, 20, 22, 23.
So
And
can you
the X1,
and
the X1, I have negative 3, negative 2, 0, 2, 3. Hello.
Yeah.
So the X1 is the total destiny is equal to 100. So dividing it by the what do you call it?
The n.
The number of, sorry, yes,
Divide
dividing
by
by the
n.
n. Yes, when you divide it by n, you are getting 20.
You see,
Then
I want
the
you to
MD.
appreciate. Hello, sir. I want you to appreciate the steps. If the values in the model are different, it gives you the opportunity to solve it yourself and get it done. The process is the same.
Okay.
The process is the same. Right? So don't be bothered about the value.
Right.
Be bothered about the process. Hello.
But,
yes, sir.
So because of the figures are different, it sometimes gives confusion. Or if you are looking at your own and our own,
That's right.
sometimes it gives us confusion.
No, it shouldn't confuse you. It shouldn't confuse you in any way. Yes.
So please, a humble submission. So,
okay.
Please, you see what Master is doing. He's using a slice. So, and after the lecture, he do send us the slice, and then there is a model. So, if you send us the slice and you follow the slice, you can solve whatever is in the model. So, this one is doing is his own slice, but I use the same formula what is in the model. So, there's no difference between them. So let's relax. When you finish, he will give us the slides and then we'll follow them. I think it will be fine. Thank you, sir.
Okay, sir. Okay, sir.
Let's not be bothered about the values. I understand where you're coming from. You want everything from the model should be here so that you can easily. You're not going to learn the model again. But it's the same process. This is calculation, the same process. So that when you pick the model and you go through the same process, you should be fine. You'll be fine. Now let's look at mean deviation for group data. Mean deviation for group data. Right, for group data. So here, let me just and then this one there, where we are going to confusion. So I can give you the X values. I'll give you the Y F values for group data, X and F. Right. And this is the formula. As you can see, summation F bar X minus the mean, introduce the bar all over summation F. That's the formula. I always tell my student, let the formula guide you. Let the formula guide you. So what we need is the mean. So for group data, the mean formula is also there. Summation Fx over summation F. Summation Fx over summation F. So we need to find the x's values are here. We have single values for x. So this is not where you're going to find midpoint. It's already there. So you multiply f by x for each of the rows. Then you get these fx values. Then you sum it. When you sum it, you get 1210. Then summation f, you get 40. So on this left-hand side, as you can see, 1210 over 40. And that gives us the mean of 30.25. Once we found the mean here in the formula, the next thing is subtract that from the individual scores, which is X scores. So this scores 30.5 from each of the scores. So this column is what we are talking about. So 28 minus 30.5, 30.25, it gives you negative 2.25. 29 minus 30.25, it gives you negative 1.25. 30 minus 30.25, it gives you negative 0.25. 31 minus 30.25 gives you this. 32 minus 30.25 gives you this. 30 minus 30.25 gives you that. After you have found the deviation, the next one is introduce the bar in the formula. Introduce the bars. So the next column, you introduce the bars. And I told you that once the bars are introduced, every negative becomes positive.
Yes, sir.
Are you with me? Yes.
So that bar, we call it absolute value.
The absolute values. Okay,
Yes,
that's
sir.
fine. So you introduce the, if I say absolute values again, so the bar is quite simple to know it's a bar. So basically, you introduce those bars to make the values absolute, change from negative to what? Positive, as you can see. So negative to negative all becomes positives. Is that clear? At this point, are we okay?
Yes, sir.
Yes, sir.
Now, in the formula, after you have introduced the absolute values or the bars, right? It says there's an F. F means that you have to multiply these absolute values by its corresponding frequency, which is F. So here we move to the next. So here we multiply the absolute values by the frequency. So F5 times 5.25, it gives you 11.25. 9 times 1.25 gives us 11.25. 8 times 0.25 gives us 2. 10 times 0.75 gives us 7.5. 5 times 1.75 gives us 8.75. 3 times 2.75 gives us 8.25. Are you with me?
Yes, sir.
At this level, at this point, are we okay?
Yes, sir.
Yes, sir.
Now, in the formula, once you have multiplied the F by the absolute values, you sum it. That's what the formula is saying. Let the formula guide you. Sum it. So you're going to add all this. When we add all this, we get summation F times the absolute values, which gives us 49. 49. Then over summation F, then we add this frequency, summation F, and get 40. Once we're able to do that, we get MD is equal to 49 over 40, which is 1.225. So the individual scores are deviated from the mean by 1.225. Please, are we clear?
Yes, sir.
Hello?
Hi.
Yes, sir.
Shall we continue?
Yes, sir.
So please go over again. My network jam out in the middle of.
Which part should I go over? Is it the whole thing again, or at a point where it went off? Which part?
Yes, the mean deviation. I believe it. I don't.
For group data.
Hello.
Hello.
Yes, sir.
Is it for the group data or the raw data?
Both.
Hello.
So we should go back to the previous one. This one. We should go back to this one.
No, please.
This is the raw data. I'm asking you the group data.
Yes, please.
Okay. So for group data, we'll give you the X and the frequency, like it's being shown to you right now. The formula is mean deviation is equal to summation F absolute X minus the mean, right? You introduce the bars over summation F. Do you understand? That's the formula. You need to learn it. But please, can you hear me now? I don't want to go over and you complain I didn't hear anything.
Yes, I can hear you, sir.
Okay. In the formula, you need the mean. You see, this bar, X bar, you need the mean. How do you get the mean? The mean formula is summation Fx for group data is summation Fx over summation F. So it means that you need to hello, lady who couldn't hear me. Can you hear me now? Hello.
Sorry, is this
Yes, sir.
difficult to?
That is good.
It's
Hello,
determined.
class.
It's determined.
Hello.
You know, this one involves a lot of concentration and exhaustion.
Please, can you hear me?
We can hear you. Yes, sir, we can hear you.
Oh, but the lady who asked the question, is she around?
Yes, sir. Sir, my network is terrible, so I'll suggest you continue. I'll go through alone. When I'm not getting it, maybe I'll.
Thank you. Please, can you hear me now?
Loud and clear.
Yes.
Yes, sir, we can hear you.
Hello. Hello.
Hi, sir.
Let's move on. Later, probably you can ask your friends to help you out because I can't go back and later the same I can't hear you issues. All right. The next thing we need to do is variance and standard deviation. Variance and standard deviation. We'll look at it at the raw data, and we also look for the group data, right? The raw data and the group data. Variance is defined as the average of the square deviations from the mean. And this is the formula. This is the variance formula. Again, I will tell you to learn the formulas because you may not get the formula sheet during exams. Then the standard deviation is this formula. So the difference between variance and standard deviation is that one has square root. The standard deviation has a square root on it, but the variance is the same formula, but there's no square root on it. So standard deviation is the square root of the variance. When you put the square root on this formula, it becomes standard deviation. Okay. So let's do it for raw data, then we can do it for group data later on. Now, assuming I ask you to find the variance and standard deviation of the following, this data. This particular data, X is 35, 45, 30, 35, 40, 25. In the formula, so you have to turn it vertical so that the X can follow like that. So this formula, you need the mean. You need the mean, right? The mean is giving us summation X over N. So when we add all these X values, we get 210 over 6, 35. Then subtract the mean from the individual scores, as the formula is asking you to do. So the next is you subtracting the mean from the individual scores. So 35 minus the mean is 35. 45 minus 35. 30 minus 35. Down to 25 minus 35. When we subtract, we get these values. You get these values, as you can see, right? Now the formula is saying that after you have subtracted, subtracted, please you can write.
Yes, sir.
After you have subtracted the X from the mean, you get these values. Then the formula says square it. So whatever value you are getting, X minus the mean squared, you square these values. 0, 100. -5 times -5 is 25. Then this is 0, this is 25, and this is also 100. After that, the formula is saying that sum it. Sum. So you add all these values, you get 250. So 250 over N. N is the number of observation, which is 6. 1, 2, 3, 4, 5, 6. Right. 250 over 6 to get 41.7. So here you get 41.7 for the variance. Now, if you want to find the standard deviation, it is square root of the same formula. So when you put square root of 41.7, you get the standard deviation value. Please, is that clear?
Yes, sir.
Please, if you have any issue, let me know so that I explain it.
So explain that side again, please.
Which side?
The square side, please.
The standard deviation formula is square root summation into bracket X minus the mean squared all over N. But you see, the variance is also the same formula. The only difference is this one, there's a square root on it. So if you get the variance answer and you put the square root on that answer, you get a standard deviation. Do you understand?
Yes, sir. Yes, sir.
Okay. Standard deviation is 6.5. You can use the values under the paint. You see the paint, brand A, brand B paint. I give you some values. You can use it to calculate for the variance and standard deviation at your own, free time, just to know how it goes. Right. Now, let's also find variance and standard deviation for group data. This is the formula for variance for group data, and this is the same formula for standard deviation for group data. It's the same. Again, it's the same, except here we've put the square root on it for standard deviation. So the formula is summation fx squared minus summation fx all squared over n all over n minus 1. I know that the formulas are complex and sometimes it may confuse you, but make time and learn them. The standard deviation is the same thing, just that here we have put a square root on it. So we can look at examples. Let's look at examples. We are finding the variance and standard deviation that on the number of miles 20 runners run during 1 week. So this is the first column is the X, and this is what the frequency column. So here we have to find X. How do we find X? Use one value to represent X. How do we do it? Anybody? How do we find X? Because in the formula, we need to find X. How do we find X?
So we'll find it by taking the lower limit and the upper limit. We'll add it and divide by 2. So we'll get the midpoint.
Fantastic. So you need to find a midpoint. So the midpoint, one value to represent X for each of the classes. Have you seen it? One value. So 5.5 plus 10.5 over 2 gives you 8. You do same for the rest, subsequent ones. It will give you the midpoint values. So you find the X values. In the formula, once you have found X, you see summation f x squared. Here it's telling us that we have to square X, the X values, multiply what we get by F and sum it. This side is telling us multiply F by X, sum it, then later square that value you sum. So the formula should guide you. So this is Fx, this second one, F times X. So Fx, you multiply F times X, you get this. Then you sum it. Once you sum it, you put it here in a formula. Now the other side too is X squared. This one is the Fx squared. You square X squared is 8 squared is 64. 64 times F, which is 1, is also 64. 13 squared. When you square 13, you multiply by 2, you get 338 over here. 18 times 18 times 3. Whatever you get times 3 will give you 972. Please, can you see it?
Yes, sir.
Aha. So the formula is saying that square the X. After squaring the X, multiply by 8F. So 8 squared, 64 times 1, which is F, 1, is the same 64. 13 squared, whatever you get, times 2, 338. 18 squared times 3. This is what you do for the Fx squared here. Then you sum it. When you sum, you get 13310. So this 13310 is what you're going to put over here. Minus 490 here squared over n. N is the summation f, 20. All over 20 minus 1. So that is what we'll be doing. This is it. 13,310 minus 490 all squared all over n, which is 20, all over 20 minus 1. When you break it down, 490 squared gives us 240,100 over 20, all over 20 minus 1. When we divide this by 20, we get 12,005 over here, minus 13,310. Then we get, when we subtract this from this, 1,305 over 20 minus 1 is what? 19. So the variance here is 68.7.
Sir.
Is on the variance answer 68.7.
Sir.
Is it clear?
Yes.
Yes.
Yes, sir.
Sir.
I have a question, Master.
One at a time, please.
So yeah, in finding the values for the x and then the fx and then the f. Hello, sir. Hello.
I'm listening.
Sir, I'm saying that, yes, sir. I'm saying that in finding the values for x and then the fx and then the fx squared in exams, do you need to show working to get those values, or once you are able to provide that in the table, it's enough for you to go ahead with the formula and then work for your values?
No. We just complete. Do you understand? Hello?
I didn't get it, sir.
Do you understand? I said that you don't need to show working. Just make sure that the table is complete. You can do the working on your calculator and put the values in the table.
That's fine. That's fine. Thank you, sir.
Sir.
I'm okay now, sir. I'm fine, sir.
The network is very bad.
Sir, with the fx square, I want to know whether you have.
No. Sir, I did.
Robert, you want to know what?
Sir, with the fx square, sir, do you have to square the midpoint, which is the x, before you multiply, or you multiply before you square?
Oh, look at the formula. Look at the formula. The square is affecting the x, not f. Robert.
So the square is only affecting the x.
Yes, can't you see?
So the network is not that, I don't know.
The square is only affecting the x. That's why we square the x first.
So it's a 13 squared.
Whatever you get.
160 multiply by 2.
What? Yes.
338. Okay. Okay,
yes.
Sir.
Do you understand?
Sir. Thank you. Yes, sir. Yes, sir.
Okay. So the only difference between standard deviation and variance is that one has a square root. The other, so when you calculate the variance, you put the square root on the answer. That answer becomes your standard deviation answer. Please, is that okay?
Okay, sir.
Now let's go on with coefficient of variation. Then I think we'll be done for today. Coefficient of variation. The coefficient of variation is obtained by dividing the standard deviation by the mean. the result is always expressed in percentage. So this is a statistic that allows one to compare standard deviation when the units are different. So this is the formula. Standard deviation over the mean times 100 is the coefficient of variation. So if I ask you a question like, the mean of the number of sales of cars over 3 month period is 87, and the standard deviation is 5, then the mean of the commission is 5,225, and the standard deviation on that commission is 775. Compare the variations of the two. So standard deviation of cars, when you sell the car, is 5. Then the mean for sales of cars is 87. Then when you sell a car, the commission you get, the standard deviation is 773. Then the mean for the commission you get for selling a car is 5,225. Right. How do we calculate for the coefficient of variation? As the formula is saying, it is standard deviation over the mean times 100. So basically, it is, I don't know whether you can see, because it's in the blue. Let me see whether you can see it well. Okay. Okay, probably let me try and change the okay. If I highlight it, maybe you see it well. Okay, can you see it well? Can you see it now? So what we are saying is that with this, the standard deviation for sales is 5. The mean is 87 times 100. It gives you 5.7% sales. Then commission, 773, standard deviation is 773 over the mean is 5,225 times 100. It gives you a commission of 14.8% commission. So since the coefficient of variation is larger for commission, the commission it means that commissions are more variable than the sales. I mean, commissions are larger than the sales. That is what it implies here. Then we have a trial question. The mean for the number of pages of a sample of women's fitness magazine, the mean is 132. Then the variance is 23. Then the mean for the number of adverts of a sample of women fitness magazine is 182, and the variance is 62. Compare the variation. So with this, the formula is what? Standard deviation over mean. But in this question, we have given you variance. How do you get the standard deviation from this variance so that you can use it to calculate? Can anybody help us? Can anyone help us? How do we get standard deviation from this?
Sir,
anyone?
If I quite remember, you say we have to square root it. So we'll square root that one to get the other one.
Yes. Yes. So that you can use that
so we
figure.
have the square root on the calculator. So we just point it and add the figure to it. Then we'll get the accurate mean.
So you have to square root of 23 to get the standard deviation for the number of pages. Then you also have square root of 62 to get the number of adverts done, so that you can use it to calculate for the coefficient of variation, which is standard deviation over mean. So in the formula, it is standard deviation, not variance. So you have to change this variance to standard deviation by square rooting the values to get the standard deviation value. Then you put it in this formula to get the coefficient of variation for each of the, items. Please, is that clear? Please, is it clear?
Yes, sir.
Yes, sir.
Okay. So do you have any question? If you have any question, please ask. If not, we want to end our lecture today. I know it is quite, tedious and quite complex. But I believe if you take your time and you go over it systematically, you should get everything we have discussed. All right.
Yeah, hello.
Yes.
Yeah, manager.
If there are no questions, I would like us to end. All right, so let's end the lecture and have a lovely day.
Thank you, sir.
Thank you, sir.